Hello, it's Alex here, Victor Kilo 2 Papa Radio Charlie. I'm a very big Clansman enthusiast and I live here in Australia, right into the 320s and 351s, etc, etc, etc. Got a bit of a project here, my latest project, and I'd like to share it with you all and explain to you exactly how I've done it. I'm sure there may be people out there in the world that are very, very interested in this particular project and may want to follow along and do similar to what I've done. But before I describe exactly what I've done, I'd like to first thank Craig, EA1JCA in Spain, for inspiring me to do this particular project and to supply me with a lot of information, including the original line diagrams and his views on modifications. I'd also like to thank Peter, VK2PRC down in Victoria, for his special little circuit for eliminating the noise on electronics projects. We'll leave it at that for now. I'll explain exactly what that's all about as we get into the project. But okay, let's unveil it and see what it is. Shock horror. There it is, a Clansman 320 with a DDS variable frequency oscillator fitted. My God. If you're a purist, you're probably cringing at this point. But please rest assured that no Clansman radio, a going Clansman radio, was ruined to do this project. In fact, I'll just pick it up here. We started off with two of these, complete wrecks. Okay. Wrecks, when I say wrecks, the radios that had the synthesizer completely shot. So for those of you who know all about Clansman 320s, they have all sorts of faults, mainly power supply faults, but we all know that when they start to get that tone that won't stop, it's usually the kiss of death of a dead synthesizer. So once the synthesizer's dead, basically the radio's ready for retirement, destined for the spares bin, too expensive to repair, too hard to repair, can't get synthesizers, changing them is very risky, you could get one, put it in, blow it up, etc. It's just bad news. So sometimes it's easier to try and acquire another radio. Yeah. So I had a couple of these laying around, some dead ones. So I got the idea, along with Craig, to install a DDS variable frequency oscillator to the radio and bring it back to life. So, and that's exactly what I've done, and it works extremely well. So before we look at the project in detail, I think it's a really good idea if we have a look at the basic line diagram of the radio and talk about what was changed to make my Clansman 320 digital. Okay, here we are with the line diagram of the 320. Here you'll see the power supply section, that's unit 5. That's going to be very important for our new conversion. That remains unchanged. Over here we've got the unit 8. Unit 8 is the reference oscillator for the radio. It produces a 1.75 megahertz square wave as a clock for the synthesizer, and also a sinusoidal same frequency wave to run the mixers, etc. Okay, we've got the synthesizer, we've got the selection front panel switches. Okay, we've got unit 3H, which is in the turret and creates the variable frequency oscillator for the radio, and we've got the 3A board in the turret for the receive tuning as well. Okay, so basically this is sort of how it works. The reference oscillator here makes a nice reference oscillator to run the whole set, so it's all synchronized. You dial in the front frequency, the synthesizer checks that frequency, sends a DC voltage up here to 3H. 3H creates the variable frequency that you've selected on the front dial switches, shoots that frequency up into board 6. Okay. It also shoots it across to the receive over here, so that the receive's on the same page, so it's receiving and transmitting the same frequency. It also sends a little bit of a check signal back here to the synthesizer. I should say that's where it is there, the check signal. The synthesizer looks at the check signal, and if it's not quite right on frequency, it'll vary the DC voltage up here. This will change the frequency ever so slightly, so we end up with a closed loop system where the synthesizer's constantly checking what the 3H board's doing and correcting it. And that's basically how the Clansman works as it is now. Now it's worth mentioning here, the power supply that we're going to use for our conversion is in fact the original power supply. We're going to use the 110 volts, we're going to use the 12 and the 6, the 3 won't be required. But if you've got a dead set that doesn't have a good power supply, there's no reason why you couldn't make a replacement power supply just using the cheap modules that you buy on YouTube and one of those Nixie tube high voltage supplies you can get to produce the 110. So that's possible to do for the conversion. Just moving across here to the main oscillator, unit 8. It's worth mentioning that when we do a conversion to lower sideband for the 320, what we do is in fact we remove this 1.75 megahertz supply and we replace it with another integrated circuit with an oscillator on it that produces 1.7468. So actually we cut that wire there and introduce a new oscillator to give us the lower sideband. Okay, the original unit here still maintains the 1.75 square wave to run the system through the synthesizer, but that's how that's done. So if you want to do a conversion and you want to just have upper sideband, then there's no need to replace the unit 8. You can just run the unit 8 as it is. But if you remove the unit 8 and replace it with a fixed frequency oscillator that can be switched between 1.75 and 1.7468, then you can introduce lower sideband to your conversion. So that's an option, either to remove that or leave it there. Okay. Another thing here that's worth mentioning is when this particular system is all set up and it's working as it is, there's a permissive section of the radio here that turns the tone off and allows the radio to transmit and whatnot. This little permission gate here, and for our conversion, that little wire there is very important because that's actually got to end up being earthed so that the radio will operate. Because at the moment that signal to that wire there is controlled by the existing synthesizer. So there you go. So what we're going to do the conversion, we're going to remove the synthesizer and all the associated switching. We're going to remove the 3H board and all of the associated frequency generation that happens there. We're going to replace it with a DDS variable frequency oscillator with 1 or 2 outputs. One to control the fixed frequency oscillator and the other one for the variable frequency oscillator. Okay, so I might add at this point that when we remove the synthesizer, identify all the wires when you pull it out, because you're going to need to know where they go, because some of them may end up being reused. As the same goes with the 3A board. Identify these wires, identify the supplies, and whatnot. We'll get to all of those soon. Yeah, when I describe the conversion. So Now we'll have a look at the line diagram after it's been changed to the conversion. We'll start off here over on the left hand side of the diagram, and that was the permission cable that came from the synthesizer that I said that needed to be grounded. So that has to be identified from the synthesizer because that will eventually be grounded. So that's the very first part of our conversion. We'll come over here and you'll notice that the synthesizer is now gone. Okay, and in this case it's been replaced by an Arduino DDS. Now the Arduino DDS is one option if you don't want to use or make up and program an Arduino specifically for this conversion. You can simply buy something off the shelf like I've done and use it instead of the Arduino. Okay, but that replaces the fixed oscillator, the unit 8, and it also replaces the synthesizer, which is now gone as well. Okay, so how it all works is the Arduino will generate, in this case, two frequencies. One will be the IF frequency for the 1.75 sinusoidal wave, and it comes out of these units as a square wave. It has to be shaped. We're going to talk about that in a little while as well. And that shoots the variable frequency oscillator. Where's my little pointer? There it is. There. Variable frequency oscillator comes out of the Arduino, comes over here to where the 3H board used to be, and it's split into two here, and one of the variable frequency goes to board 6, the main board, the motherboard, so to speak, and the other one goes down and across and over here to the receive board, the 3A board. Okay, and how we do the tuning of the radio is via a variable resistor that we set up here to generate the high voltage or the low voltage depending on what frequency you're at, and that applies it to the VK2PRC diodes over here, and that'll tune the radio manually. So what you do is you simply tune it for the greatest noise on that particular band. It's a very, very easy thing to do, and I'll be showing you how to do that a little bit later in the video. Okay, so synthesizer out, unit 8 out, replaced by an Arduino or a variable frequency oscillator in the form of a DDS, still using the original power supplies to generate power for these things. So yeah, that's basically it. And of course the earthing, let's go and have a bit of a look here at the permissive one, as I said. The earthing of this particular cable is important, otherwise the radio won't work. So we do that as well. Okay, and that's that in essence is the line diagram for the replacement of the synthesizer, the main reference oscillator if required, and as I said, we don't really need to do that, and we can even use the original power supply if it's working. So yeah, it doesn't sound like that much of a big deal, and to tell you the truth, it isn't really. Once you've got the radio pulled apart and trace all the wires, it's not that hard. Okay, amplitudes, wave shapes and frequencies are all very important, so we're going to cover those next. We're going to have a really good look at those after we have a look at the radio. We're going to have a look at the radio now, go over the mechanics of what I've just described, and then we'll come back and look at some nitty-gritty drawings. Okay, I'm going to assume at this point that most people that are looking at this video have a pretty good understanding of how to pull a Clansman apart, and I've probably worked on them before. So in order to access the turret here, by the way, I've got all this radio is all back together again, but nevertheless you'll get the idea. So the whole idea is we've got to remove the tuning part of the radio, which is very, very easy. 4 screws, 2 on the bottom. This comes out. There's one wire to disconnect. I think this one here, I haven't connected it back up again. There's that wire there. It connects onto there, so that's pretty easy. You unsolder that wire. Whole unit is removed. Then you just use a screwdriver through those holes and take off the 4 posts. That clears this whole area out, so you can take the cover off here and a cover off here. Yep, okay. So once you do that, it gives you access to the 3H board and the 3A board. Okay, easily done. Okay, next what we want to do is get some access to remove the synthesizer. So you'll see some screws there with the green holes around them, green paint around them. Those 3 screws come out. I think there's another one over here on this side. You can just see it there. That comes out as well. And then underneath, I'll just turn the radio over. You remove all of the screws that hold the motherboard on. They've all got little green circles around the screws. They all come off. Then the whole board, the section comes out. The whole board then swivels up like that. And what I normally do is get a screwdriver and put it up there like that to hinge the board up in that position. Gives you access to all the screws underneath that hold the synthesizer in. There's a couple of little screws here on the side too that come out. You'll see those, are pretty easy. And that gets you the synthesizer and unit 8 are mounted on a bracket, and that bracket becomes wobbly and you can pull it out and move it around. While you're under there, there's one screw down here that needs to come out. You'll see it underneath. That's associated with holding the front onto the rest of the chassis of the radio. You need to remove that screw there as well, and that one in there, that one there, and that one needs to be removed as well. Because not only are we going to get access to remove the synthesizer, but we need to get access to the front of the radio to take the switches off, the band selection, not the band selection, the frequency selection switches. Okay, so once we've got access to that, then you'll find yourself with this particular bracket here that mounted the synthesizer here and the unit 8 here. That'll be out and flopping around. So, okay, now there's a screw here and there's another one down in there. You can just see it down in there where my finger is. Those 2 screws there come out, then the whole chassis of the radio pulls back away from the front, and you can bend it down, so it leaves a big gap down in through here. Okay, so now you've got access to all the wiring and all the front selector switches as well, so you can pull all the knobs off. As I was saying, this will get you access to the front of the radio here, so you can remove all of the decade switches, all the associated wiring, and all of the backing of the switches. You can pull the wiring out then, and you can start looking at removing the synthesizer. And as I said, you need to identify the wires coming out of the synthesizer as you remove them. Now there'll be supply wires too. You need to identify 6-volt wires, 12-volt wires, and 110-volt wires. You'll also need to identify some of the cables that the screen cables that go from here over to the tuner. Okay, so once you get all the debris removed out of here and all the wires identified, it is a bit of an arduous job, but you'll certainly learn all about the radio as you do that. That's for sure. Okay, so once you get over that done, then you find yourself over here at the tuning section. So it's time to remove the 3H board out of there and identify all of the wires as well from the diagrams. I might note here that that one of the wires that comes out of here was the wire that used to produce the variable frequency for this number 6 board underneath, and that wire went I think down and across and ended up around here, those blue wires, and ended up at the number 6 board. So that particular wire, what I did with mine, I pulled it all the way back to the number 6 board and then rerouted it over to the synthesizer area, because my new DDS is in this area, so I actually used that wire to drive the signal back to the number 6 board. Then I run a new screen cable from this area here over to the tuning area, and that was the variable frequency for the tuner. I used some speaker cable, single core, tiny little speaker cable that was screened, and that was what I used there. You also need to run another wire from this area, another screen cable over here, which will be the new DC variable supply to tune the tuner. Okay, So that's basically what we're doing as far as pulling things apart. Okay, so now let's have a bit of a look at what we're putting in. Okay, it's hard to do this with one hand on the telephone to do the recording. So what I've done basically, I've used these standoffs that I bought in the electronics shop, and I've mounted basically two little pieces of probably, I think it's called Vero board, and I've manufactured the electronic circuits on there, and I've also put a third one over here in this area here. Okay, so let's have a look at what I've actually done, and then we'll go and have a look on the drawings. So we'll get to the unit in a minute. Okay, so what I've done here, I've incorporated on the backboard here a DC filtering circuit to filter the supply from the radio, the 12-volt supply, to drive my DDS unit. And according to Victor Kilo 3YE, these particular units, they make a lot of noise. So that noise ends up being heard in the headphones when you're receiving. So a couple of capacitors, a couple of resistors in here, I was able to put that circuit on the Vero board, eliminated all the noise. So that's my thank you very much to Peter down there in Victoria. Also, coming out of here, we've got the variable frequency oscillator to drive the radio, and on that board there, I've split that frequency into two sections and attenuated it to drive the number 6 board underneath and to drive the number 3A board over here. So you set up your voltage amplitudes using some little pots that I've put on that board there. I'm going to show you that in detail. Over here on the front board, this is associated with the fixed frequency oscillator that I've used to drive my radio, and I've made my radio so that I can change the fixed frequency oscillator so that I can have both upper and lower sideband on the radio by simply either switching a switch with some of the DDSs that you can get, or simply going in and reprogramming a different frequency for the fixed frequency oscillator. Okay, and that's all incorporated on here. And the filtering system for this is very, very important. And I got that off a chap in the UK, off his conversion to lower sideband for the 3.5. Hang on, the Clansman 321 radio, I think it was. He incorporated this beautiful little filter that does exactly the same thing, and we'll be talking about that in a few minutes as well. So that's what's incorporated on these boards here. Also, you need an amplitude regulator on this one to get the right 300 millivolts for that as well. Now over here on this little board here, I've just created a simple 555 timer circuit and an attenuator circuit to give me the right wave shape amplitudes. I've just used a 555 timer here to generate 2 kilohertz, and that signal there goes into the 1A board, and that's your 2 kilohertz tone for tuning and for CW. Okay, so yeah, basically that's it. So let's have a look on the front. Now on the front of it, the first thing I want to talk about is the variable potentiometer on the front, this one here. This is the tuning one that you tune the receive. You just simply, to operate the radio, get the right band selection, tune for the greatest noise, and away you go. Dial up the frequency and start transmitting and receiving. It's as easy as that. And that particular unit there is a potentiometer unit with a couple of resistors, and I've mounted that completely all on the one unit down in there. You can see the back of the potentiometer. It's got a little capacitor there that I've incorporated as well. I'll put a picture of that in the video so that you can have a look at that in detail. So it's all completely inbuilt into the back of that. Okay, so that's that part of it. And of course the DDS that I've used, that one there. Yeah, this particular conversion was a prototype conversion. So if I was to do this again, I'd probably do it differently, make it a little bit more aesthetically correct. Possibly I would use the little tuner here. I'd probably mount it on the side, one of these holes, and make it the whole thing a lot flatter. Perhaps mount this a bit further back. Perhaps mount a different LCD display. There's so many different options that you could do. Yeah, look, the mind could create all sorts of front panels to do this job. But as I said, I only did this one as an initial exercise to see if it could be done, and that's the way that I mounted it. So there you go. So yeah, that's basically it. We've got, look, I've got a little switch here on the side. This particular switch, the way that I've made it a little bit different than a normal Clansman. I've actually switched the 2 kilohertz for the tuning, so I can actually switch the tuning oscillator on or turn it off depending if I want to tune to an antenna or not, so it just doesn't run all the time. Okay, so that's basically it. I used one of the existing holes that I took out of one of the selection switch to run the cables into the set, and yeah, basically that's it. So we've got the rheostat for tuning in the receive and transmit, which is a very, that sounds scary, but it's not. It's very, very easy to do. We've got the unit here where we select both the variable frequency for the different bands, and we can also change the fixed frequency for upper and lower sideband. And pretty well, other than that, the radio operates as normal. Okay, so there she is. As I say, this was a prototype, and it was made up of 2 wrecks of radios that were absolutely useless. In fact, I had to construct a new base for this. I didn't even have one. I had to make a new steel base for it. I changed parts from another radio, the number 6 C and D board. In this was shot. I took it out of that other decrepit set, and eventually made 2 otherwise useless sets into one. Well, we'll call it a Clansman 320D for digital. So there you go. Okay, so what we're going to do now is we're going to have a look at some of these individual circuits on here and how to build them. Okay, the first one that I want to talk about is this little one here that I built in here. This is the smoothing DC filtering circuit to supply the 12 volts for the DDS. And this was compliments of Peter down in Victoria. Okay, so here's your DDS, and capacitor, a resistor, and a capacitor, and that goes then to your 12 volt supply. So it's as simple as that. Without this, you get a persistent hum in the radio that is enough to drive anybody crazy. But Peter has cured this by this simple little circuit. If you want to freeze the video here and make a copy of this, this is an essential. Doesn't matter what DDS unit you use. Okay, the next one that I want to talk about is the potentiometer circuit here. And this is basically the potentiometer circuit. Starts off with the 110 volts in the top. I've got a voltage divider network set up with a 4K at the top and a 1.5 at the bottom, and that gives me a voltage spread here to here of I think plus 5 volts at the bottom and down to about 85 volts at the top. Variable rheostat of 25K will give me the variation between those voltages. I've slipped in a capacitor here to do a little bit of smoothing if required, probably not even needed, but I used it anyway. And that goes off to the 3A board and does the tuning. As I mentioned, that was a rheostat at the front that you tune up to get your receive and transmit spot on. So if you'd like to freeze the video there, that's that circuit. Okay, the next one that I want to talk about is the fixed frequency oscillator attenuation and smoothing circuit on this board here. So over here, coming out of the DDS, you've got your fixed frequency oscillator. This is going to run the radio's upper and lower sideband. Okay, we've got some load resistors here to give us a nice 50 ohm load, 2 in parallel. We've got a pot in here, one of these little pots that go on the PC board that you can twiddle with a screwdriver to get the right amplitude. So that's going to be the amplitude regulation to get this to 300 millivolts peak to peak. Down here, through this simple smoothing circuit that I got off the chap in the UK, we're just using some RF chokes and some ceramic capacitors, and that will give us an absolute beautiful sinusoidal wave at 300 millivolts peak to peak, and that's tuned up here. Okay, and that goes off down to the number 6 board. So if you want to freeze the video, that's it. The next one that I want to talk about is situated on the rear board here. This is the variable frequency oscillator for both the number 6 board and the number 3A board. Okay, so here is what I've done. Coming out of the DDS, we've got our variable frequency oscillator. I've got a network I should say, of 3 resistors giving me a 50 ohm load, all in parallel. These are these little variable resistors that you get, that you twiddle with a screwdriver that mount on a PC board. They're 200 ohms. And these are the takeoffs that are going to regulate the amplitude of the wave for me. Some isolating 10 nanofarad capacitors, one on each. So we've got these one supply, variable frequency supply coming out of the DDS, and it's split into 2 here, where we can regulate the amplitude on either. This one here is going to go to the 3A board, and that's the cable that's got to go from the rear of here over to the 3A board. And we've got this one over here that goes down to the number 6 board, and that was the cable that I said that I rerouted back around and over to here to accommodate that one. So if you want to do a snapshot of that, I'll see if I can make sure that's focused right. There you go, and that's that. Lastly, we need the 2 kilohertz to drive the tone generator for the 1A board, and this is what I've used, just a simple 555 timer with the associated electronic parts. I used a very simple circuit for this one. I'm not going to describe how it works, but that's basically it. It's just a little 555 timer with some resistors and capacitors there that give you the square wave of approximately 2 kilohertz. I've used this voltage divider network here to get me the right amplitude of 1.7 volts peak to peak, and that's shot over here into the 1A board. So basically, there it is there. Make sure it's try and focus there, if you want to freeze that. Okay, definitely worth having a look at this one. This is a drawing of the main board underneath the number 6 motherboard. Now, test point L, this is where your variable frequency oscillator comes down from the DDS. It leaves up here via the potentiometer that you can regulate the wave shape to about 300 millivolts peak to peak. But down here on the number 6 board, there's another voltage divider network that reduces that down to 150 millivolts at that point there. So what you need to do is twiddle your pot up here and monitor down here to get that 150 millivolts, and that'll be smack on what the previous setup was on the standard radio. Down here on this 6B board, number 8 terminal, this is where the fixed reference oscillator comes in here, and that is tuned to the 300 millivolts peak to peak, and that's either the upper or the lower sideband frequency. So that's 2 of the test points that you need to be aware of on the number 6 board to do this conversion. There you go. Alright, I've slipped the 2 halves of the radio back together and turned her on. I'll just give you a brief rundown on how it all operates. Okay, so basically you would have your band switch in the normal band position like normal. You would dial up the frequency that you want to use in that band. In this case, I'm on 40 meter band. You would simply vary the resistor. You can probably hear the hissing going on down there. You can vary it's getting soft, yep. So basically you just tune it up for the highest hissing, and that's there. I don't have an antenna connected. If I did, it would be a lot louder, a lot more significant. Simple. So once you get that set, that's it. Don't have to touch it again. Okay, the unit that I used here was a very, very good little unit that I found on the internet. I bought that from ozqrp.com.au. Comes with a superb 30-page manual. Any idiot could follow it. Better than the Chinese rubbish that you buy, that you get with no instructions in it. Okay, I'll give you a bit of a rundown on how I use this one. To program it, you just push the rotary encoder in, it'll come up with a menu. I'll click down here for full menu and march through the menu. First thing that comes up is the fixed frequency. Do you want one? Yes, I do. then you set the frequency up by just stepping across with the other button and setting up the numbers with the encoder, and that's the fixed frequency for my lower sideband, and you can change that to high sideband if you want to. Okay, this is the IF offset. Clansman requires an IF offset always above the VFO, and that's selected there. That's where you dial that offset in, and it's always 1.75 above the VFO. This is the lower one that I don't use, and it comes up and says the transmit frequency, and this is where you dial in the transmit frequency that you want it to come on when you first turn the radio on. So it's as simple as that. These are the steps, the tuning steps that are available once the radio's in operation. They're great, I like that. Okay, then you just save all that stuff. Some calibration, very, very important that you calibrate this thing, very, very important. It's not right when you buy it. You need to do it by a beat test, or you need to use a super accurate frequency meter, or get on the air with someone to help you calibrate this thing. So you can put some offset frequencies in here to get the thing calibrated perfectly. Once it's done forever. Okay, important that. We've got some more setups here with voltages and alarms for voltages and sidebands that I don't use, and there's a couple of things there that aren't really that important to me, and that's pretty well how it all operates. So there you go, guys. That's the radio done. Giving you a pretty good tour of it. I'm going to slip it all back together now, and I'm going to go up to the park, set it up, and I'll just give you a demo on the air, and you'll be all interested in just how it goes. I mentioned before about a short required to earth to give the radio permission to transmit. The signal would normally come from the synthesizer. We don't have one of those anymore, so we need to have it permanently turned on. And here we are on the 6 board. So that's the little link there that I've soldered in. You can see. I think you're pretty clear on that. There it is on the 6 board. And there it is. That's the little link that I've put in, and that earths that little permissive relay, well, solid state relay there, which enables the radio to operate. Right, we're up here at the park to test out the radio. I'm just running my usual halfway for 20 metre, quarter wave 40 metre vertical with my coupler there. That I've got videos up on YouTube if you want to have a look at them, how to make it. I also sell them and make them for people as well, so there you go. But anyway, here we've got the set up. So we've we can actually hear a station there that's been tuned in. I'll just okay, so there she is, she's on the air. So what we're going to do now is we're going to try and make a few contacts. Just to show you how to tune it, you select the band as per normal, and we're going to tune. For maximum noise, select the frequency you want, and get on the air. It's that simple. So yeah, I'll see if I can make a couple of contacts and see if we can record them as well. VK2PRC. Good afternoon, this is Victor Kilo 2 Papa Radio Charlie. It's Alex here, mate. Up in the park at the moment, Campbelltown, New South Wales, over.
Oh, there you go. Good on you, Alex. You got Mark on the microphone here. Mike Alpha Radio Kilo. I've got your 5'9", a little bit over. So whatever you're up to there, Alex is doing a great job into my spot. I'm just out of the park as well, Stanwell Tops, just out of the National Park. But we're sitting at home in the shack. VK2PRC, pedestrian, I think portable, VK2 Papa Hotel.
Yeah, VK2 Papa Hotel, Stanwell Tops. I know it well, mate. I get down there now and then on the lookout and set up there in the park myself. Good spot for DXing, have it?
Yeah, good on you, Alex. Well, where the hang gliders are there at home, that's our spot, just across the road. So pretty spoilt for area, and also a nice place to play radio. Enjoy, mate, coming through beautifully. I hope you're all well. Campbelltown, here on the coast, gorgeous afternoon. So enjoy it while we can. VK2PRC, VK2PH.
VK2PH, your signal strength's lovely, mate. You're a 59 plus here with me as well. To get 59 plus with you is great. How's my audio sounding? By the way, I'm using a Clansman 320 military radio at this end, over.
Yeah, I thought so, Alex. Well, it sounds very narrow, as you would expect. Very, very good radio audio. And it's sounding fine, mate. It's sounding fine on my speaker. Radio here, using receive and transmit to Kenwood, the TS990. But certainly doing a great job for an old girl military rig, mate. Fantastic to keep it going. VK2PRC, VK2PH.
Yeah, thanks for the flowers, mate. Okay, VK2PH, thank you very much for the contact. This is Victor Kilo 2 Papa Radio Charlie, mate. 73, bye-bye.
Have a great arvo, mate. 73.
Well, there we have it. Not only has it been resurrected from the dead, but it works very well. So very, very pleased with my project, and more so than ever, being able to resurrect a couple of radios from nothing to operate as a digital front end. Yeah, it's 320, which is really pleasing. So hopefully anybody out there that wants to follow along in my footsteps, I hope I've given a pretty good detailed explanation of how it's done. And of course I'm always there at the other end of the email for anybody that's really got any questions. So thanks very much, guys, for watching my video. I'll stay here for the rest of the afternoon, perhaps get a little bit of DX into Europe as well. So there you go. This is Alex, Victor Kilo 2 Papa Radio Charlie, saying farewell.